Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area of a rectangle practice questions. If you need any extra help on finding the area of a rectangle, if you go to corbettmaths.com/contents and scroll down to video number 45, there's a video tutorial there on how to find the area of a rectangle and square. Alternatively, you could scan this QR code and that'll bring you straight to that video tutorial. Okay, but in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So let's have a look at question number 1. So question number 1 says, on the grid below, each square represents 1 centimetre by 1 centimetre, and we've been asked to draw a rectangle with area 10 centimetres squared. Well, if each square has a length of 1 centimetre and a width of 1 centimetre, each square has an area of 1 centimetre squared. So we just need to draw a rectangle which has got 10 squares inside of it then. So then that would have an area of 10 centimetres squared. So get your ruler and pencil. So in terms of our rectangle, we could draw a 10 by 1 rectangle, but that probably wouldn't fit on this grid. So I'm going to draw a 5 by 2 rectangle. I'm going to do 5 centimetres across, 1, 2, 3, 4, 5. And I'm going to do a width of 2 centimetres, 1, 2, and then go across and then join up. So that's a 5 centimetre by 2 centimetre rectangle, and it should have an area of 10 centimetres squared. And let's just check it. So it's 5 centimetres long and 2 centimetres wide. And if we check its area, it's got an area of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this area is 10 centimetres squared. And that's it. Okay, let's have a look at our next question. Question number 2. So question number 2 says, on the grid below, each square represents 1 centimetre by 1 centimetre. So it's again another centimetre square grid. And we've been asked to draw a rectangle with an area of 8 centimetres squared. So a rectangle with 8 centimetre squares inside of it. So that could be a 1, 2, 3, 4, 5, 6, 7, 8. It could be an 8 by 1 rectangle, or we could do a 4 by 2. I'm going to go for 4 by 2 rectangle. So it would look something like this. So it would have a width of 2, 1, 2, and it'd have a length of 4, 1, 2, 3, 4. And then if we finish off the rectangle, it would look something like that with a length of 4 centimetres, so 4 centimetres, and a width of 2 centimetres. And again, if we check its area, 1, 2, 3, 4, 5, 6, 7, 8. So the area is 8 centimetres squared, and that's it. Okay, let's have a look at question number 3. So question number 3, we've been given a rectangle. The diagram shows a rectangle, and the rectangle's got a length of 12 centimetres and a width of 3 centimetres. We've been asked to work out the area of the rectangle and to include our units. So to find the area of a rectangle, we do the length multiplied by the width. So we multiply how long the rectangle is by how wide the rectangle is. So if we do 12 multiplied by 3, we will find the area of this rectangle. So we're going to do 12 multiplied by 3, and 12 multiplied by 3 is equal to 36. So our answer would be 36. Now we were dealing with centimetres and centimetres, so it's going to be centimetres squared. So answer would be 36 centimetres squared. 36 centimetres squared. So to find the area of a rectangle, you just multiply the length by the width, and then make sure you put the units on as well. Okay, question number 4. So question number 4 says, shown below is a rectangle. So we've got this rectangle. It's got a length of 7 centimetres and a width of 3 centimetres. And we've been asked to work out its area. So again, to get the area, we're going to do the length multiplied by the width. So the area is equal to the length multiplied by the width. So it's going to be 7 multiplied by 3. And 7 times 3 is equal to 21. So the area would be 21. And then we're dealing with centimetres here. So centimetres squared. So let's write that in the answer box, 21. Okay, our next question, question number 5. So question number 5 says, the diagram shows a rectangle. So we've got this rectangle, and it's got a length of 12 centimetres, and we don't know the width of the rectangle, and we're told the length of the rectangle is 12 centimetres. Yep, we know that. The area of the rectangle is 48 centimetres squared, so the area is 48 centimetres squared. And we've been asked to find the width of the rectangle. So if we know the area and we've got its length, to find the width, we'll do the area divided by the length, because the length times the width gives us our area. So if we do the area divided by the length, we'll find our width. So we're going to do 48 divided by 12. And 48 divided by 12 is equal to 4. So it means the width of this rectangle would be 4 centimetres. So the width of the rectangle is 4 centimetres. We can check our answer because we can do 4 multiplied by 12, and 4 times 12 is 48. So that's right. So the width of this rectangle is 4 centimetres by just dividing the area by the length to find the width. Okay, question number 6. So question number 6 is a calculator question, and we've got a rectangle. It's got a length of 4.5 centimetres and a width of 2.8 centimetres, and we've been asked to work out the area of the rectangle. So the area is equal to the length multiplied by the width. So we're going to do the length, which is 4.5, and we're going to multiply by the width, which is 2.8. So we're going to do 4.5 times 2.8. So on my calculator, 4.5 multiplied by 2.8 equals 12.6. So 12.6, and we're dealing with centimetres and centimetres, so there would be 12.6 centimetres squared. So the answer is 12.6 centimetres squared. Okay, let's have a look at our next question. Question number 7. So question number 7, we've got a rectangle, and this time we've got its length is 68 centimeters and its width is 43 centimeters. And we've been asked to work out the area of the rectangle, and it's a non-calculator question. So to find the area for this rectangle, we're going to need to do the length, which is 68, times the width, which is 43, but without a calculator. So the area is equal to the length multiplied by the width. So it's going to be 68 multiplied by 43, and we're going to need to do that. So 68 multiplied by 43. So let's do 68 times 3. So 3 times 8 is 24. Put the 4 down, carry the 2. And then 3 times 6 is 18, plus 2 is 20. So 3 times 68 is 204. Now we're going to do 40 multiplied by 68. So put our 0 down, and we'll do 4 times 8. 4 times 8 is 32. Put the 2 down, carry the 3. 4 times 6 is equal to 24, plus 3 is 27. So 40 multiplied by 68 is 2,720. So now we just need to add them together. 4 plus 0 is 4. 0 plus 2 is 2. 2 plus 7 is 9, and then 2. So the answer would be 2,924. So the answer is equal to 2,924 centimeters squared. And we'll just write that in the answer box, 2,924. Okay, question number 8. Question number 8, we've been told that the width of a rectangle is 28 centimeters, and the area of the rectangle is 1,540 centimeters squared. And we've been asked to work out the length of the rectangle. So to find the area of 1,540, we would have done the width multiplied by the length. So to find the length, we just need to take the area and divide it by the width. So we need to do 1,540 and divide it by 28, and that would tell us how long the rectangle would have been. So if we do, and it's a calculator question, 1,540 divided by 28, that's equal to 55. So that means that this rectangle would have had a length of 55 centimeters. And we can check our answer. We can do the length times the width and see if we get the area. So 55 multiplied by 28 is 1,540. So the answer, the length of our rectangle, is 55 centimeters. Okay, our next question. Okay, let's have a look at question number 9. So question number 9 says, shown below is a wooden picture frame. So we've got this wooden picture frame. The height of it is 14 centimeters and the width is 12 centimeters. Then in the middle, we've got the space where the picture will go, and it's got a height of 10 centimeters and a width of 8 centimeters. And we've been asked to work out the shaded area, so this brown area. And that would be, if you looked at the photo frame, I suppose the wooden area of the front. So we want to work out the area of the shaded region here. So what we're going to do is we're going to work out the area of the whole thing. So we're going to do 12 multiplied by 14 to get the area of the whole thing. Then what we'll do is we'll find the area of this other wide rectangle in the middle. So we're going to do 10 times 8, and then we'll take them away to see what's left for the shaded area. So first of all, we need to do 12 multiplied by 14. So we're going to do 12 multiplied by 14. That's a non-calculator question. So we're going to do 14 multiplied by 12, just setting it up like so. And we're going to start by doing 2 times 14, and then we'll do 10 times 14. So let's do 2 times 14 to begin with. So 2 times 4 is 8. And then 2 times 1 is 2, so that's 28. Then we're going to do 10 times 14, so put our 0 down. 1 times 4 is 4, and 1 times 1 is 1, so that would be 140. And then adding them together will tell us 12 times 14. So 8 plus 0 is 8, 2 plus 4 is 6, and then 1. So the area of the whole photo frame would be 168 centimeters squared. So that's the area for the whole thing. Now what we need to do is do 8 times 10. So we're going to do 8 times 10, and that's equal to 80 centimeters squared. So the area for this region in the middle would be 80 centimeters squared. And then if we take the 80 away from the 168, that will tell us the area of the shaded region. So we're going to do 168 take away 80 and see what we get, and that will be the answer. That will be answer. So let's do our 168, subtract 80. So 8 take away 0 is 8. 6 take away 8, let's borrow, so that'll be 16 take away 8, which is 8. So the answer would be 88 centimeters squared. So that means that the shaded region has got an area of 88 centimeters squared. The region in the middle is 80 centimeters squared, and they would add together to be the area of the whole thing. So that's right. So the shaded region has got an area of 88 centimeters squared. So let's write that down, 88. Okay, question number 10. So question number 10, we've got this rectangle, and we've got its length being y, that's how long it is, and we've got its width is 5 centimeters, and we're told its area is 65 centimeters squared. And we've been asked to work out the size of y, the length of the rectangle. Well, the length times the width is equal to the area. So that means that the area divided by the width will give us the length. So 65 divided by 5. And let's use our bus shelter method because it is a non-calculator question. How many 5s go into 6? 1. Remainder 1. How many 5s go into 13? 3. So that means the length of the rectangle is 13 centimeters, and that's it. So y is 13 centimeters. And we could check our answer. If the length is 13, if we do 13 times 5, that's equal to 65, which is the area. So we know that we're right. Okay, let's have a look at our next question. Question number 11. So question number 11 says the perimeter of a square is 28 centimeters. Find the area of the square. So let's do a little sketch here. So here we've got our square, and we know the perimeter of the square is 28 centimeters. So that means if we add up the distances, the lengths of all four sides, we get 28 centimeters. So if we add up this length, this length, this length, and this length, we should get 28 centimeters. So that means if we take our 28 and divide it by 4, we will find the length of each side of the square. So if we do 28 divided by 4, that's equal to 7. So that means that the length of the square is equal to 7 centimeters. And let's just check it. If it was 7 plus 7 plus 7 plus 7, 7 plus 7 is 14. Plus 7 is 21, plus 7 is 28. So that means the perimeter of the square would be 28 centimeters. So we've been asked to find the area for the square. Well, the width of the square is 7 centimeters, and the height of the square is 7 centimeters, because this is 7 by 7 square. And if we do 7 multiplied by 7, we will find the area for the square. So 7 times 7 is equal to 49. So the area of the square would be 49 centimeters squared. Okay, let's have a look at question number 12. Question number 12 says, the rectangle below has an area of 36 centimeters squared, and it's got a length of 9 centimeters and a width of 4 centimeters, and 9 times 4 is 36, so that's right. And we've been asked to write down the length and the width of two other rectangles that have got an area of 36 centimeters squared. So that means that if you look at this rectangle, we know that the area is equal to the length multiplied by the width. And whenever we do the length, which is 9, multiplied by the width, which is 4, 9 times 4 is equal to 36. So we want to find another rectangle, which whenever we multiply the length and the width together, we will get 36. So there's loads of options here, infinitely many, I suppose. We could do 36 multiplied by 1, because 36 long multiplied by a width of 1, 36 times 1 is 36, so that would equal 36 centimeters squared. We could do 18 multiplied by 2, and that would be equal to 36 centimeters squared. We could do 12 multiplied by 3, and that would be equal to 36 centimeters squared. So all of these would be possible options. It could have a length of 36 and a width of 1 centimeter, a length of 18 centimeters and a width of 2 centimeters, a length of 12 centimeters, a width of 3 centimeters. We could even have decimal numbers. We could do 10 multiplied by 3.6 is equal to 36 centimeters squared. So that means that the length would be 10 centimeters and the width would be 3.6 centimeters. We could even do 72 multiplied by half, 0.5, because 72 halves is 36 centimeters squared, and so on. There's loads of possible options that we could choose from. As long as we choose two positive numbers, which will multiply together to give us 36 centimeters squared, then that's an option. Okay, so let's write that down. So let's write down, first one could be 36 centimeters by 1 centimeter. We could choose 18 centimeters by 2 centimeters. We could even choose 72 multiplied by 0.5 or 10 multiplied by 3.6 and so on. Okay, let's have a look at our next question. So question number 13 says, shown below is a square and a rectangle. So we've got this square and we've got this rectangle. And the square has got a width of 8 centimeters, and that means obviously its height would be 8 centimeters as well, because we've a squared, the length and the width are the same. And we've got this rectangle, and it's got a length of 16 centimeters and a width of y. And we're told the square and the rectangle have the same area. Find y. Okay, so they've got the same area. So let's find the area of the square to begin with. Then we know the area of the rectangle because they're the same, and then we can find the width of the rectangle. So let's start off with the square. So with the square, we're going to find its area. So we're going to do 8 multiplied by 8. So 8 multiplied by 8 is equal to 64 centimeters squared. So that's the area of the square. Now with the rectangle, we know then that the area of the rectangle would be 64 centimeters squared as well. So that would be 64 centimeters squared as well for its area. So if we know what the area is, then we can just divide it by the length then to find the width. So if we do 64 divided by 16, that will give us how wide the rectangle is, the width of the rectangle. So if we take the area and divide it by the length, we will get the width. So we just need to see how many 16s go into 64. This is a non-calculator question, so let's consider our multiples of 16. We've got 16, 16 plus 16 is 32, plus another 16 is 48, plus another 16 is 64. So we've got 1, 2, 3, 4 16s in 64. So that means that 64 divided by 16 would be 4. So that means that the width of the rectangle would be 4 centimeters. So just to recap, we find the area of the square by doing 8 times 8 is 64. We know that because the length times the width is equal to the area, if we divide the area by the length, we'll find the width. So we do 64, because it's the same area, 64 divided by 16, and that's equal to 4. So that means the width of the rectangle, y, is equal to 4 centimeters. And let's write that down. Okay, question number 14. Question number 14, it's a non-calculator question, and we've been asked to work out the area of the rectangle below. And the rectangle has got a length of 7.5 meters and a width of 3 meters, and we've been asked to include our units. So to find the area of the rectangle, area is equal to the length multiplied by the width. The length of the rectangle is 7.5 meters, so 7.5, and the width is equal to 3 meters, so times 3. So we're going to do 7.5 multiplied by 3. That's a non-calculator question, so we could do 7.5 plus 7.5 plus 7.5 and add them up that way to get 3 lots of 7.5. So that would be, lining up the decimal points, 5 plus 5 plus 5 is 15, so put our 5 down, carry our 1. 7 plus 7 plus 7 is 21, plus 1 is 22. So the answer would be 22.5. Alternatively, you could do 7.5 times 3. This is how I would do it, and put the points line up the decimal points. So 3 times 5 is 15, put our 5 down, carry a 1. And 3 times 7 is 21, plus 1 is 22. So the answer would be, or the area would be 22.5. And also we need to include our units, so we're dealing with meters here, so answer would be meters squared. So the answer would be 22.5 meters squared. Okay, question number 15. So question number 15, we're told that a rectangle is 3 centimeters wide by 6 centimeters long, and 6 of the rectangles are used to make a larger rectangle. So we've got 6 of these smaller rectangles, 1, 2, 3, 4, 5, 6, and they're put together to make this larger rectangle. And we've been asked to work out the area of the larger rectangle. Now there's two different ways you can approach this. One approach would be to get the area of the smaller rectangle, so do 3 times 6, which is equal to 18 centimeters squared. And then because there's 1, 2, 3, 4, 5, 6 of them that have been put together, you could just do 6 times 18, and that will give you the area of the whole larger rectangle. So that would be one approach, which would be fine. Also, we could just get the dimensions of this rectangle and then find the area of this one. So if we have a look at this smaller rectangle, you can see that this has got a length of 6 centimeters, and that's this distance here. So that means that the width of the longer rectangle is 6 centimeters. Now in terms of the length of the longer rectangle or the larger rectangle, we have got the 3 centimeters here, the 6 centimeters here, the 3 centimeters there, and then the 6 centimeters there. So we've got the 3, the 6, the 3, and the 6. And altogether that would be 3 plus 6, which is 9, plus 3, which is 12, plus 6, which is 18. So the length of the whole thing would be 18 centimeters long. So to get the area of the whole thing, we just need to do 18 multiplied by 6. And that was the same as the first approach, where we would find the area of one rectangle, which is 18 centimeters squared, and then just times it by 6. So you can see that we would get the same answer using both approaches. So we've got the dimensions for the larger rectangle being 6 centimeters wide and 18 centimeters long. So let's do 18 multiplied by 6 and see what we get. So 6 times 8 is equal to 48. So put our 8 down, carry our 4. And 6 times 1 is 6, plus 4 is 10. So the answer would be 108 centimeters squared. And let's write that down. 108 centimeters squared. Okay, let's have a look at question number 16. So question number 16 says the diagram below shows a rectangle, and we've got a length of 6 meters and a width of 5 centimeters, and we're told not to scale. And we've been asked to work out the area of the rectangle and to give our answer in centimeters squared. So that means that we want to work out the area of this rectangle. So the width of the rectangle is 5 centimeters and the length of the rectangle is 6 meters, but we've been asked to give our answer in centimeters squared, so let's change our 6 meters into centimeters squared. So 1 meter is equal to 100 centimeters. If you look at a meter stick or a meter ruler, you'll see there's 100 centimeters in it. So 6 meters would be equal to 600 centimeters. So that means that the length of this rectangle is 6 meters, but we could also consider it as 600 centimeters. So to find the area, we need to do the length multiplied by the width. So area is equal to length multiplied by the width. So the length is 600 and the width is 5. So if we do 600 multiplied by 5, we'll get our answer. 600 times 5 is equal to, well, 6 times 5 is 30. Add our 2 zeros would be 3,000 centimeters squared. And that's it. So the area of this rectangle is 3,000 centimeters squared. And this question is quite important because it just goes to show that if you are finding the area of a rectangle, it is very important that you're dealing with the same units before you do your multiplications. So you wouldn't just do 6 times 5 here because one's in meters and one's in centimeters. Okay, let's have a look at our next question. Question number 17. So question number 17 says, Jessica wants to lay artificial grass in her rectangular garden. So this is her rectangular garden. It's 16 meters by 12 meters. And we're told that each square meter of artificial grass costs £23. So for 1 square meter, it's £23. How much should Jessica pay for the artificial grass? So first of all, let's find the area of this rectangle, the area of her garden. So the area of her garden will be equal to the length, which is 16, multiplied by the width, which is equal to 12, and that will be equal to the area of the garden. So let's do 16 multiplied by 12, and it's a calculator question. So 16 multiplied by 12 is equal to 192 meters squared. So her garden has an area of 192 square meters. So we now know the area of the whole garden. Each square meter of artificial grass costs £23. Now each square metre costs £23. Her garden is 192 square metres, so that means she needs to pay 192 lots of £23. And if we want to work out what the total price would be for 192 lots of £23, we would do 192 times £23 and see what we get. So 192 multiplied by 23 is equal to £4,416. So the cost for the artificial grass is £4,416. Okay, question number 18. So question number 18 says, on the grid below, each square represents 1 centimetre by 1 centimetre. So each square has got a length of 1 centimetre and a width of 1 centimetre. In other words, it's got an area of 1 centimetre squared. And a rectangle has got an area of 36 centimetres squared. The length of the rectangle is 4 times greater than the width of the rectangle. Draw the rectangle on the grid. So we're told that the area of the rectangle is 36 centimetres squared. So we want to find a rectangle when we do the length times the width that will give us an area of 36 centimetres squared. So if we had a length of 36 centimetres and a width of 1 centimetre, if we times those together, we would get 36 centimetres squared. But we're told the length of the rectangle is 4 times greater than the width. But here you can see the length is much more than 4 times bigger than the width. It's actually 36 times bigger, so that wouldn't work. So we could choose another length and another width. We could choose 18 centimetres and 2 centimetres, because 18 multiplied by 2 is 36 centimetres squared. But here, the length of the rectangle isn't 4 times greater than the width, it's actually 9 times bigger, so that's not going to work either. So now let's consider perhaps 12 centimetres and 3 centimetres. Well, 12 times 3 is 36 centimetres squared, that's great. And is the length of the rectangle 4 times greater than the width? Well, 4 times 3 is 12, so that is 4 times bigger. The length of the rectangle is 4 times bigger than the width of the rectangle, so that is the rectangle that we want. We want the rectangle that is 12 centimetres long and 3 centimetres wide. So let's draw that. So we've drawn the rectangle. It's got a length of 12 centimetres and it's got a width of 3 centimetres. And as you can see, its area is 36 centimetres squared and the length of it is 4 times greater than the width of it. So that's it. So that's question number 18. So let's have a look at question number 19. So question number 19. So question number 19 says, here's a rectangle with a perimeter of 30 centimetres. So this rectangle has got a perimeter of 30 centimetres. And we're told that the length of the rectangle is 10 centimetres and to work out the area of the rectangle. So to find the area of the rectangle, we were going to need to do the length multiplied by the width. But we don't know the width yet. So what we need to do is work out the width and then we can do the length multiplied by the width to get the area. So we're told the perimeter of the rectangle is 30 centimetres. So that means the distance around the outside is 30 centimetres. So that's going to be 10 plus something plus 10 plus something is equal to 30. So let's do 10 plus 10 and see what that is equal to. 10 plus 10 is equal to 20. So the total length of these two sides is 20 centimetres. Now the whole perimeter is 30, so if we do 30 take away 20, that would tell us that there's 10 centimetres left for the other two sides. And if we divide that by 2, because they're both the same, if we do 10 divided by 2, that's equal to 5 centimetres. So that means that the left-hand side must be 5 centimetres, this width, and this width is equal to 5 centimetres also. So that is the length and the width of the rectangle. It's got a length of 10 centimetres and a width of 5 centimetres. And let's just check it. 10 plus 5 is 15, plus 10 is 25, plus 5 is 30. So that's it. So that's our rectangle. We've been asked to work out the area of the rectangle. So the area is equal to the length multiplied by the width. So it's going to be the length, which is 10, multiplied by the width, which is 5. So 10 multiplied by 5 is equal to 50 centimetres squared. So the area of the rectangle is 50 centimetres squared. Okay, let's have a look at our next question. Question number 20. So question number 20, we've been given this rectangle. It's got a length of 18 metres and a width of 8 metres. And Mrs. Jenkins is a chicken farmer. So she's a chicken farmer. And this is her pen, her chicken pen. And it's 18 metres long and 8 metres wide. And each chicken requires at least 3 metres squared of space, 3 square metres. So that's how much space each chicken requires. What is the maximum number of chickens that Mrs. Jenkins can keep? So first of all, let's find the area of her chicken pen. So let's do 18 multiplied by 8 to get the area of this chicken pen to begin with. That's a non-calculator question, so we're going to need to do 18 multiplied by 8 and see what we get. 8 times 8 is 64, so put our 4 down, carry our 6. 8 times 1 is 8, plus 6 is equal to 14. So the area of this chicken pen is 144 square metres, or 144 metres squared. And each chicken requires at least 3 metres squared of space. So what we need to do is divide the total area by 3 to see how many chickens then can fit into this pen. So we're going to do 144 divided by 3. So let's use our brush shelter method. 144 divided by 3. So how many 3's go into 1? 0, remainder 1. How many 3's go into 14? Well, that's going to be 4, remainder 2. And how many 3's go into 24? That's going to be 8. So the answer would be 48. So how many chickens can Mrs. Jenkins keep? 48. So let's have a look at question number 21. So question number 21 says, shown below is a cuboid. So here we've got a cuboid, and the base of the cuboid is a square. So this is a square. This at the bottom of the cuboid is a square, and it'll have a length and a width that are the same size. So it might be a 10 centimeter by 10 centimeter base, or a 2 centimeter by 2 centimeter base, but the length and the width of the square will be the same. And the height of the cuboid is 15 centimeters. So the height of the cuboid here, the height of it is 15 centimeters. And we're told the total length of the 12 edges. So there's 12 edges, a cuboid has 12 edges. 1, 2, 3, 4. And then we've got 4 vertical ones. 1, 2, 3, 4. And 4 more edges at the base. 1, 2, 3, 4. So it's going to be 12. 4 plus 4 plus 4 is 12. So the total length of the 12 edges is 112 centimeters. So we've got the length of all of those edges. And we've been asked to find the area of the base of the cuboid. So we've been asked to find the area of this base of the cuboid. So we need to find the length and the width of that square on the base. So we need to find the length of that edge and the length of that edge. And we're told the total length of the 12 edges is 112 centimeters. Now we're told that this length, this height is 15 centimeters. So that means that this edge has got a length of 15 centimeters. Well, that also means that that edge would have a length of 15 centimeters, that edge would have a length of 15 centimeters, and that edge at the back would have a length of 15 centimeters. So that would be 15 centimeters, this one at the back would be 15 centimeters, and this one here at the front right would be 15 centimeters also. So we've got the length of 4 of the edges, but we've also got 8 left. 1, 2, 3, 4, 5, 6, 7, 8. But because we know the base of the shape is a square, the base of the cuboid is a square, so that means that that edge would have the same length as that edge, which would be the same length as that edge, which would be the same length as that edge, which would also be the same length as that one, and that one, and that one. So all of those 8 edges that are left have got the same length as each other. So that means we know enough information to work out the length of each one of those edges. Because we know if we add together our 4 15s and take that away from 112, then what's left would be the length of the 8 remaining edges. They're all the same, so if you then divide that by 8, you can find the size of one of them. So let's do that. So let's do 15 plus 15 plus 15 plus 15. This is a calculator question, but we can do it without it. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. So the total length of those 4 vertical edges would be 60 centimeters. But we're told the total length of all 12 edges is 112. So if we take the 60 centimeters away from the 112, we can then see the total length of the 8 remaining edges. So if we do 112 take away 60, and 112 take away 60 is equal to 52 centimeters. So that means that the combined length of the 8 remaining edges would be 52 centimeters. So if we divide 52 by 8, because they're all the same size, that will tell us the length of one of the edges. So 52 divided by 8. I'm going to do this on my calculator. And that's equal to 6.5 centimeters. So that means that each one of these edges has got a length of 6.5 centimeters. So 6.5 centimeters, 6.5 centimeters, and so on. All of them would be 6.5 centimeters. And we could check we're right. We could add together 4 15s and 8 6.5 centimeters, and that then should be equal to 112 centimeters. Now the question asks us to find the area of the base of the cuboid. So we want to find the area of the base. So the base is a square, and it's got a length of 6.5 centimeters and a width of 6.5 centimeters. So if we do 6.5 multiplied by 6.5, that will give us the area of the base of the cuboid. And that is equal to 42.25 centimeters squared. And that's it. So the area of the base of the cuboid is 42.25 centimeters squared. So question number 22. Rory made a rectangular logo which is 8 centimeters long and 5 centimeters wide. And there are 5 identical white squares and the rest of the logo is shaded. So we've got these 5 white squares and the rest of the logo is shaded. And we're asked to find the area of the logo that is shaded. So we want to find this shaded area, this yellow area. Okay, so first of all, we can find out the area of the whole rectangle. That's going to be 8 multiplied by 5. So let's do that. 8 multiplied by 5 is equal to 40 centimeters squared. So the area of the whole rectangle is 40 centimeters squared. But we want to find the shaded area, this yellow area. So what we want to do is we want to find the area of the 5 squares and take them away from 40 to see what's left, and then that will be our answer. So what we need to do is we need to find the area of one of these squares. So let's do that. So the whole shape has got a length of 8 centimeters. So the whole thing is 8 centimeters long. But if you look, that is the length of 1, 2, 3, 4, 5 squares. So if we take our 8 centimeters and divide it by 5, we will find the length of each square. We will find how long this distance is because it's the same for each of them because they're identical. So let's do 8 divided by 5, and that would tell us the length of one of the squares. So 8 divided by 5 is equal to 1.6. So that means each square is 1.6 centimeters long. That would be 1.6 centimeters. 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 And that length would be 1.6 centimeters. In other words, the 5 1.6s, the lengths, would have to add together to be 8. And 5 times 1.6 is 8 centimeters. So we know the length of the square. And remember, it's a square, so that means the width will be the same. So that'll be 1.6 centimeters also. So we can then find the area of one of our squares. We could do 1.6 multiplied by 1.6, and that will give us the area of one of our squares. So let's do that. So 1.6 multiplied by 1.6 is equal to 2.56 centimeters squared. So each square has got an area of 2.56 centimeters squared. So that's, a square's got an area of 2.56, that square's got an area of 2.56, that square's got an area of 2.56, that square's got an area of 2.56, and that square's got an area of 2.56 centimeters squared. So what we can do now, to find the shaded area, this yellow area, we could take 40 and take away 2.56, 2.56, 2.56, 2.56, and 2.56 and see what's left. Alternatively, we could take our 2.56 and multiply it by 5 to get the total area of these 5 squares. So 2.56 multiplied by 5 and see what that is. So multiplied by 5 is equal to 12.8, so 12.8 centimeters squared. So that's the total area of those 5 squares. And then if we take that away from 40, that will tell us what's left. So 40 take away 12.8 is equal to 27.2 centimeters squared. So the area of the logo that is shaded is 27.2 centimeters squared. And that's it. Okay, let's have a look at question number 23. So question number 23 says, shown below is a rectangle with a length of 20 centimeters and a width of 10 centimeters. And we're told that the length of the rectangle is increased by 20%. So this length is going to get bigger by 20%. So it's going to go up by 20%. And the width of the rectangle is increased by 5%, so that's going to go up by 5%. And we've been asked to find the percentage increase in the area of the rectangle. So we want to find the percentage increase of the area of the rectangle. So let's find the area of the rectangle to begin with. So the area is equal to the length multiplied by the width. So the length is 20 and the width is 10, so 20 times 10, so 20 times 10 is equal to 200 centimeters squared. So that's the area of the rectangle to begin with. Now what we want to do is increase the length by 20% and increase the width by 5%, see what those are, multiply them together, and then that will give us the area of the larger rectangle, and then we can work out the percentage increase. So let's increase the length by 20%. So we've got a length of 20%, so we're then going to find 10%. So for the length, 10% of 20, well 10% of 20 is equal to 2, because if you divide 20 by 10, that gives you 10%, so that's 2 centimeters. We want to find 20%, so that's going to be double that, so that's going to be equal to 4 centimeters. So 20% of 20 is equal to 4 centimeters. So that means that 20% of 20 is equal to 4 centimeters, getting 10% and doubling it. So we want to increase by 20%, so that means we want to take our original length, which is 20, and add 4, so that means that our new length will be 24 centimeters. So we're going to have a new rectangle that's got a length of 24 centimeters. Now the width, so the width of the rectangle was 10 centimeters, but it gets increased by 5%. So we want to work out what 5% of 10 centimeters is. So let's find out 10% to begin with. So 10% of 10 is equal to get 10%, you divide by 10, so it's going to be 10 divided by 10 is 1, so 10% is equal to 1 centimeter. 5% will be half of that, so 5% will be half of that, which is 0.5 centimeters. So the width is increased by 5%, so there's going to be an increase of 0.5 centimeters, so it's going to be 10 plus 0.5, which is equal to 10.5 centimeters. So we now know what the new length is and the new width of the rectangle. So we can then times them together to get the area of the new rectangle. So we're going to do the area is equal to the length multiplied by the width. The length was equal to 24, multiplied by the width, 10.5. And then when we times them together, and luckily it's a calculator question, so 24 multiplied by 10.5 is equal to 252 centimeters squared. So we have the original area, which is 200 centimeters squared, and we've got the new area, which is 252 centimeters squared. And we've been asked to find the percentage increase of the area of the rectangle. So to find the percentage increase, we're then going to do the change divided by the original, and then change that into a percentage. So the change is, well, it's gone from 200 up to 252, so the change is 52. We're then going to divide that by the original area, which was 200, and then change that to a percentage. So that gives us 52 divided by 200, or 52 200ths, and as a decimal number that would be equal to 0.26. Let's change that to a percentage, that would be 26%. So the percentage increase in the area of the rectangle would be 26%. Okay, question number 24. Question number 24 says, Rebecca draws a rectangle, Holly enlarges the rectangle by scale factor 2, and Rebecca states the area will be twice as large as the original rectangle. Show Rebecca is incorrect. So with a question like this, I like to start off with a rectangle, so let's sketch one. So I've sketched a rectangle here, and I'm going to give it a length of 5 centimeters and a width of 3 centimeters. So I'm just going to make up a length and a width for my rectangle. And then we're going to enlarge it by scale factor 2. So that means double the width and double the length, and see what we get. So I've enlarged the rectangle by scale factor 2. The original length was 5 centimeters, so the new length will be 10 centimeters. And the original width was 3 centimeters, so when we double that, that'll be 6 centimeters. So let's find the areas and see if Rebecca's correct. So Rebecca said that the area of the larger one will be twice the area of the original one. So the area of this rectangle will be equal to the length times the width, so that's going to be 5 times 3, which is equal to 15 centimeters squared. If Rebecca's correct, then that means that the area of this one must be 30, because it would be double. So let's find the area of this rectangle. So it's going to be the length, which is 10, multiplied by the width, which is 6. 10 times 6 is equal to 60 centimeters squared. So Rebecca isn't correct. Rebecca said that the area will be twice as large as the original rectangle. And actually, if we look at these areas, we've gone from 15 to 60. So that's actually 4 times bigger. So Rebecca's incorrect. The area is actually 4 times larger. And let's write that down. And I've just written down the area is actually 4 times larger. So Rebecca's incorrect. Okay, let's have a look at question number 25. So question number 25, shown below rectangles A and B. And we've got this rectangle A, we don't know its length or its width, and we've got then rectangle B, and we've got its length or maybe width to be 32 centimeters. And we're told that both rectangles have the same area, so that's great, they've both got the same area, if we can work out the area of one of them. And we're told the perimeter of rectangle B is 114 centimeters. So that's fantastic. So that means we can work out this missing length here. And once we find this missing length, we can do the length times the width and get its area, and that'll maybe help us with rectangle A. So let's find this missing length. So we know that the length of the top here is 32 centimeters. So that means the length of the base will be 32 centimeters also. We know the total perimeter. So if we do 32 plus 32, take that away from 114, and then half it, that will then tell us this length. Okay, so 32 plus 32 is equal to 64. And then if we take the total perimeter, the 114, and take away the 64, that would tell us what's left for the other two sides. So that would be equal to 50. And then if we take our 50 and divide it by 2 because of the same length, that's equal to 25 centimeters. So that means the length here would be 25 centimeters. Actually, it's the width. So we've got the length of the rectangle is 32 and the width of the rectangle is 25. So that's going to be quite useful. And then we're told the length of rectangle A is 8 times larger than its width. Find the length of rectangle A. So let's go back. We're told that both rectangles have the same area. So let's find the area of rectangle B. So for rectangle B, we're going to do 32 multiplied by 25. And it's a calculator question. So 32 times 25 is equal to 800. So that means centimeters squared. So that means the area of this rectangle is 800 centimeters squared. So that means the area of this rectangle is 800 centimeters squared. And we're told that its length, this length is 8 times larger than its width. So we're looking for a length times a width that will give us 800, and for one of the values to be 8 times larger than the other. So for instance, if we chose a length of 400 centimeters and a width of 200 centimeters, they do times together to give us 800 centimeters squared, but the length of it isn't 8 times larger than the width, it's actually 200 times larger than the width, so that's not going to work. So if we chose a length of 80 centimeters and a width of 10 centimeters, 80 times 10 is 800. So 80 times 10 is 800 centimeters squared. And the length of the rectangle is 8 times larger than its width. So that means that the length of this rectangle would be 80 centimeters. So that was one approach, and I used the trial and error approach there. Alternatively, you could have used algebra whenever you're doing this question. So you could have said, if the length is 8 times larger than its width, if we called the width x and the length that would be 8 times larger would be 8x, we could say 8x times x is equal to 800. So we could do 8x times x is equal to 800. 8x times x is 8x squared, and that's equal to 800. One step ahead of myself there. Now we're going to divide both sides of the equation. We've got 8x squared is equal to 800. We divide both sides of the equation by 8. So we divide by 8 and divide by 8 to get that x squared is equal to 100. And then we know that it's a positive length here, so we can then work out the square root. So the square root, because it's x squared, we do the opposite of squaring, which is square root, and the square root of 100 is equal to 10. So that means that the width was equal to 10 centimeters, and the length, which is 8 times longer, would be equal to 80 centimeters. With this question, with the values, finding our 800 centimeters squared and 80 and 10, I found that quite quickly using trial and error. So that probably would have been the approach I would have used there, just working it out. But an algebraic approach could work also. Okay, let's have a look at question number 26, and it's a non-calculator question, so I'm just going to put my calculator down. And Mr. Jones is tiling his kitchen floor. So we've got this kitchen floor, it's a rectangle, and it measures 3 meters long by 2 meters wide. And he's using these tiles, and each of the tiles is 30 centimeters by 20 centimeters. And the question says, how many tiles does he need? So in a question like this, I like to figure out how many tiles would go in one row. So I would start at the bottom and I would work out how many tiles would go in each row. And then I would figure out how many rows of tiles that I would have. And then I can figure out then how many tiles I need. So the total length of this floor is 3 meters, which is 300 centimeters. Now each tile, if we look at it, has got a length of 30 centimeters. So if we done a 30 centimeter tile, another 30 centimeter tile, another 30 centimeter tile, and so on, we would do 300 divided by 30 to see how many would fit along the wall. So if we done 300 divided by 30, that's equal to 10. So that means that there'd be 10 tiles along in each row. So 1, 2, 3. I might actually start this again just so they look a bit better. So let's do that. So there's going to be 10 tiles in each row. So 1, 2, 3, 4, 5, I'm halfway, 6, 7, 8, 9, and then 10. So there's 10 tiles in a row. So that's how many tiles are in each row. So now we just need to see how many rows there would be. And the width of each tile is 20 centimeters. And the width of the floor is actually 200 centimeters because it was 2 meters. And when you times that by 100, you get 200 centimeters. So that means if we do 200 divided by 20, that will tell us how many rows there'll be. And 200 divided by 20 is equal to 10. So there'll be 10 rows. So there'll be 10 rows of 10. So there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. And 10 rows of 10 will be how many tiles we'll need, as long as none of them break or crack or whatever. So 10 multiplied by 10 is equal to 100. So he will need 100 tiles because there was 10 tiles in each row, because 300 divided by 30 is 10, so there's 10 in each row. There was 10 rows of them needed. 10 times 10 is 100. Okay, let's have a look at question number 27. It's a similar question, and we've got Jessica's tiling her bathroom wall. So we've got this bathroom wall, and it measures 240 centimeters by 200 centimeters, and her tiles are square, and they're 20 centimeters by 20 centimeters, so 20 by 20 centimeters. And each box of tiles contains 15 tiles, and they cost £8.75 for each box. How much will it cost Jessica for the tiles? So this question is just a little bit more in depth. So first of all, we need to see how many tiles she needs. So that's a bit similar to question number 26. So let's figure out how many tiles will be in each row. So they're 20 by 20, so we need to see how many 20s will fit into 240. So 240 divided by 20 is equal to, and that's a calculator question, but you can actually probably do this without a calculator, that would be equal to 12. So that means there's going to be 12 tiles in every row. So 1, 2, 3, 4, 5, 6, we're halfway, 7, 8, 9, 10, 11, 12. So there's 12 tiles in each row by doing 240 divided by 20. So that means that there'll be 12 tiles in each row. Now we just need to see how many rows there'll be. So the height of the wall is 200 centimeters. So if we do 200 divided by the height of the tile, which is 20 centimeters as well, because it's a square, and that's equal to 10. So that means there's going to be 10 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. There's going to be 10 rows of 12, so it's going to be 10 times 12. So 10 rows of 12, so that's equal to 120 tiles. So that's how many tiles that Jessica needs. So she needs 120 tiles. Now they come in boxes of 15. So let's see how many boxes she'll need. So if we divide how many tiles she needs, 120 by 15, that would tell us how many boxes she'll need. So 120 divided by 15 is equal to 8. So she's going to need 8 boxes. So she needs 8 boxes of tiles, and each box of tiles costs £8.75. So if we do 8 multiplied by £8.75, that would tell us the total cost for the tiles, and that is equal to, and that's equal to £70. So it cost Jessica £70 for the tiles. Okay, let's have a look at our next question. Okay, let's have a look at question number 28. So question number 28 says A, B, C, D is a rectangle. So we've got A, B, C, D, and it's a rectangle. And the length of the rectangle, AB, is 40% longer than the width of the rectangle. So this length is 40% bigger than that width. So for instance, if that was 100, that would be 140, 40% bigger. And we're told that a square, AEFG, is removed from the rectangle to leave a hexagon. So let's just check it's a hexagon. 1, 2, 3, 4, 5, 6 sides. Yep. We're then given these two measurements, that AG is X and that DG is 6 centimeters. So this distance is 6 centimeters and this distance is X. And we're given this ratio that whenever you take X and 6, so X to 6, and you write that as a ratio, it cancels down to be 3 to 2. So we had a ratio of X to 6, or a number to 6, and it's been cancelled down to give us the ratio 3 to 2. So whenever we cancel down a ratio, a bit like cancelling down fractions, whenever we divide both of the values by a certain number, we get 3 to 2. So we've divided 6 by 3 to get 2. That means we've divided this number by 3 to get 3. Now 3 times 3 is equal to 9, so this number must be 9. So this is 9 centimeters. And we've been asked to find the area of the hexagon, this yellow region, or this shaded region. So to find the area of this shaded region, what I would probably do is find the area of the whole rectangle if I can, and take away the area of the square, and that'll tell me what's left. So the square, it's got a height or a width of 9 centimeters. So that means that the width of it's going to be 9 centimeters. So 9 multiplied by 9 is equal to 81 centimeters squared. So this area, this square that's been removed, has got an area of 81 centimeters squared. So if I can find the area of the whole big rectangle, if I then take away 81, I'll then get the area of the hexagon that's left. So let's try and find the area of this whole big rectangle. So that's going to be the length times the width. Well, the width will be, well, that's from A to G, which is 9, and then we've got D to G, which is 6. If we do 9 plus 6, that's equal to 15. So I've just moved a bit of the working out there, just up and out of the way. It's important to leave it on the page though, so I'm just moving it on the page. And we have got our 9 centimeters and 6 centimeters here and here, so that means that the whole width of the rectangle will be 9 plus 6. 9 plus 6 is equal to 15 centimeters. So that means that DC is 15 centimeters. Now in the question we're told that the length of the rectangle AB is 40% longer than the width of the rectangle AD. So AD is the whole width of the rectangle, which is 15 centimeters. So that means that the length is 40% longer than that. So what we need to do is increase the 15 centimeters by 40%. So let's do that. So let's start with our 15 centimeters and let's find 10% of it. So 10% of 15 centimeters. To find 10%, we divide by 10, so it's going to be 1.5 centimeters. We want 40%, so we know 10% is equal to 1.5 centimeters. So to get 40%, we can just times that by 4. So 4 times 1.5 is equal to 6 centimeters. So that means that the length of the rectangle is 6 centimeters longer than the width of the rectangle, because the question said that the length of it is 40% longer. So that means if we take the width, which is 15 centimeters, and add on our 6 centimeters, we will get the total length of the rectangle. So 15 plus 6 is equal to 21 centimeters. So the whole length of the rectangle, AB, is 40% longer than this. Well, that's going to be, when we increase this by 40%, we got 15 plus 6 is equal to 21 centimeters. So the whole length of the rectangle is 21 centimeters, 21 centimeters. So we can now work out the area of the whole big rectangle by doing 21 times 15. That'll give us the area of the whole big rectangle. And then if we take away the 81, we'll then be left with the area of the hexagon. So we're going to do 15 times 21. So 15 multiplied by 21 is equal to, and it's a calculator question, so that's quite nice, 15 times 21 is equal to 315 centimeters squared. The area of the square is 81, so if we take our 315 and minus our 81, that will tell us the area of the hexagon, which is 234 centimeters squared. And that is the area of the hexagon, that shaded region, 234 centimeters squared. And that's it. This has been the video solutions to the area of a rectangle practice questions on Corbettmaths. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on area of a rectangle, if you go to corbettmaths.com/contents and scroll down to video 45, there's a video tutorial there that goes through the area of a rectangle in a bit more detail. But I hope you found this video useful. Thanks very much. Cheers. Bye.